Okay, so what we have here is we have the first lab we did, which showed our force times our time. And so this area here gave us an impulse. And that impulse caused this velocity to have a change in velocity. And so the change in velocity went from down here to up there. And that was caused by impulse. Impulse caused a change in velocity. And so here you have the same type of relationship. You have a force down here, a force graph here, and then you have a velocity graph here. But it looks like it's doing something different. And so let me draw a picture and kind of tell you what's going on. So in this case, the objects are going down a ramp. And so this would be the force here. And I have two different objects. And up here, we would have the velocity. And instead of just doing this once, I did it twice. And so what you actually have is you have at the bottom of a ramp, so you have basically a ramp. And at the bottom of the ramp, I'm going to have a little, like a little bumper. And it's connected to a force sensor. And so this force sensor here is going to be able to tell, bam, how much force is used to stop the cart, which is rolling down a hill. So this is your cart. This cart is a mass of 1 kilogram. And it's rolling down this hill, and bam, it's hitting this. The difference is there are two pieces of clay that go here. And there's a piece of clay that looks just like a sphere. And then the second one is a piece of clay, and it actually is pointed, so it looks like a cone, like this. And the question is, which one of these, and this is connected to the force sensor, and this is connected to the force sensor, which one do you think would stop the car more safely if you're going to have an accident? And how can we describe this? And so this is like an automotive crash test dummy. And so you have your crash here, and we want to find out, how do we measure these things if we were to work for GM, if we were to work for Ferrari, right? So what's going on? So we can look at the first set. And so in the first set, what's happening is actually the car starts out slow, and it's going to speed up, and it's going to hit a wall. And when it hits a wall, it's going to drop really fast down to 0, and then it's going to kind of like wobble like this. Now, we're going to contrast the two, and so maybe I could put that color, and I can say that is the cone. And let's call the sphere, sorry, that is the sphere, and we'll call the cone orange. And so I'm going to kind of slightly overlap these, and so same hill, it's going the same exact speed, so the shape should be the same, but I'm going to have the collision be, instead of the collision be here, I'm going to have the collision be right when it gets to this point of speed. This is the maximum speed, which is the same maximum speed for both of them. And then here, when it hits this cone, you're going to see that it goes like this more. And so it's slightly different in the slope on the way down. And so what is that caused by? Well, I might as well stick with the grain. So there's no force, there's no force, there's no force here on the sphere. And then when it hits, it's going to look a little bit like this. And a little bit of a mountain, right, like this. Right? And this is my force times my time, which gives me my impulse. And the impulse is the center area. I wonder if I can fill that in with a light green. There we go. And that will be the center area. And then on the other one, I have, I will stick with the orange. And so nothing's happening, nothing's happening, nothing's happening, because I'm trying to hit right here. This is where I'm going to actually have my impact. And so right there, this one is a different shape. And so how do you think this one will be different? And so this one will kind of spread out like this. And so what the heck is the difference there? So I don't know, maybe I'll choose that color right there, and I'll fill this up. All right, so what is the difference there? Well, this is also a force, and it's a time, and in the middle you have an impulse. And in both cases, this impulse causes this thing to slow down. It's a delta V, but this time it's a negative delta V. Technically, I could have this force facing the direction going down, but let's not get too technical. And then this I causes this delta V there. And so what we're supposed to do is evaluate the difference between these two. Okay, this is the first object speeding up as it goes down the ramp, and then bam, it hits and then slows down. This is the second object speeding up. It goes down the ramp, exactly the same speed. As soon as it gets the same speed, boom. And so it slows down, but it slows down slightly differently, causing these two different graphs. And so which one would you rather have as the bumper that stops you if you were a car? Now, obviously the shape, this one looks dangerous, right? But you got to remember that these are actually clay bumpers. They're made of clay. And if you know anything about modeling clay, right? Modeling clay is kind of soft. And so they are going to smoosh. I guess we could call them smushy. How would you spell smushy? Spell smushy. They're smushy. That's what they are. They're smushy. They're soft. And so it's not like you're going to run into a spike here. This is not a spear. This is just a shape that's attempting to slow down the cart. Whereas I wonder which cart. So looking at these two carts, which one is better and which one is worse for slowing you down? And so if I click on and go back to this is the two shapes of the clay that we were talking about. And I will continue this in a moment.